Hello everyone. We are going to start with the tabular format sums in the chapter of linear regression. Okay, so we'll take a few examples from our government textbook, right? And let's go to the chapter of linear regression. I'll just open the textbook at my end, mathematics part 2, right? Okay, exercise 3.1, which is on page number 41 of your government textbook. Let us solve some problems in this particular exercise. Okay, so let us take some simple example first, right? So exercise 3.1, I'm solving question number 11, which is on page number 42, okay. So now first of all, in this particular problem, x and y data is given to us. X is 1 2 3 4 5 6, and y is 2 4 7 6 5 6. Okay, and in this problem they are asking equation of y on x, and to find out y when x is equal to 10. So they are asking equation y on x, so that is y minus y bar, which is equal to byx into x minus x bar. Now x bar and y bar are the arithmetic means, byx is the regression coefficient of y on x. Fine, so we are going to solve this now. First we'll calculate x bar and y bar. X bar is equal to summation x upon n, y bar is equal to summation y upon n, right? So the total of x is 21. So this is 21 upon, there are 6 observations. If it is not divisible, don't divide this. Okay, and preferably don't divide this until the very end, whether it is divisible or not. And then the total of y is 30. So this is 30 upon 6. So we got the values of x bar and y bar. X bar, y bar values we got. Now we are supposed to calculate the value of byx, right? So I'll take a new page. Byx is nothing but regression coefficient of y on x. So covariance of xy upon standard deviation of x square, equation number 2, right? Now we'll first calculate covariance of xy. Which is summation of xy upon n minus x bar into y bar. So wherever there is summation, you have to, consider that as the next entry in our table. So summation is besides xy. So make a column of xy, or create a column of xy. So 1 into 2, that is 2. 2 into 4, that is 8. I'm multiplying these quantities. Then again 3 into 7 we need to do. 21, 24, 25 and 36. So I'm basically multiplying the two numbers over here. The total of this is 116. So this total I'll put it over here, 116 upon 6 minus 21 upon 6 into 30 by 6. Okay, so this is 116 upon 6 minus, let's multiply this, 21 into 30, which is 630 upon 36. We can take LCM now. To take LCM, we'll have to make this 6 as 36. So multiply and divide by 6 over here. Multiply by 6 and divide by 6. So this is equal to 696 minus 630 upon 36. So the final value of covariance will be 696 minus 636, which is equal to 66 upon 36. Don't divide, don't reduce. All these things we'll do at the very end. So we got the covariance of xy. This value we got, right? Now we are interested in standard deviation x square. Okay, I'll just highlight this value 66 by 36, which is equal to covariance of xy. Now don't ever calculate standard deviation directly. First calculate variance. Follow that order. Variance of x is equal to summation x square upon n minus x bar square. So summation is besides x square. Summation is besides x square. So we'll prepare that column. X square column we'll have to prepare. So we'll prepare x square. 1 square is 1, 2 square is 4, 3 square is 9, so on and so forth. Then 16, 25, 36. And the total of x square turns out to be 91. Okay, so this is 91 upon 6 minus 21 upon 6 the whole square. 91 upon 6 minus 441 upon 36. Once again we'll take LCM, multiply 91 by 6 and divide with 6. Okay, so this is equal to 546 minus upon 36 minus 441 upon 36. Okay, so this turns out to be, if I'm not wrong, it is 105 upon 36. So this is the variance of x. Okay, right? Now standard deviation of x is equal to root of variance of x. So squaring both the sides, standard deviation of x square is equal to variance of x, and variance of x we just calculated to be 105 by 36, right? So 105 by 36. Variance we just calculated. See? Okay. So go to equation number 2 now. This is equation number 2. We have covariance, we have standard deviation of x square. Put this values in equation number 2. So I'll write from 2 byx is equal to covariance is 66 upon 36 and variance, that is standard deviation of x square, is 105 by 36. So just reduce this. 66 upon 105, that is equal to it's divisible by 3. 22 upon 35. Now you can very well divide this. Okay, because again and again it's not advisable to divide and waste your time in the exam. Divide it for once. So let's calculate the value of 22 upon 35. We have to do manual division. So by dividing this we got 0.63. So byx is equal to 0.63. Now we have to put this value of byx as 0.63 in equation number 1. So from 1, I'll take you to equation number 1. See, this is equation number 1. So y minus y bar. Y bar is 30 upon 6. So this time we can take it as 5. Y minus 5 is equal to 0.63. X minus 21 upon 6. So 21 upon 6 is 7 upon 2, which is equal to 3.5. Now we can just perform some simplifications over here. 0.63 into 3.5. Once again I'm just calculating. You can also calculate it to your end. 0.63 into 3.5. You can just multiply both the terms. 2.205. So y is equal to 0.63x minus 2.205 plus 5. Y is equal to 0.63x Okay, so once again I'll just subtract 2.205 from 5, so that gives me plus 2.795. So finally we got our equation of line y on x, equation of line y on x, right? Now one more thing is asked in the question, the related part. They are asking calculate y when x is equal to 10. So they are asking find y when x is equal to 10. Okay, so y depends on x, right? So use line y on x, and y on x line is already ready with us. This is line y on x, 0.3x plus 2.795. So put x as 10 over here. So this will be 6.3 plus 2.795. So the answer will be 9.905 after the entire simplification. Okay, so this is the value of y. Okay, so this is one of the problems which I have solved for you. Fine. So let's take one more example. Go to government textbook page number 42, right? And in that, see, there is example number 6. Example number 6 in exercise 3.1. I'll not solve this, but then I'll just discuss a few things about this problem. Compute the appropriate regression equation for the following data. So which equation to find out over here? That should be a that is a task over here. Now, why is the dependent variable? Y is a dependent variable. So y depends on x. So we have to find out line, equation of line y on x. So this is asked. Okay, so don't just find out x on y. We'll have to find out line y on x over here. Okay. Now let us take one more example. Sometimes they ask you to calculate both the equations, equation of line x on y and equation of line y on x. So accordingly you can just calculate, right? So go to page number 42. Go to page number 42 of your government text, and in that there is equation number, there is this question number 9, in which x and y values are given 6, 2, 10, 4 and 8, and y values are 9, 11, 5, 8, 7. Okay, so we'll go step by step. First we'll calculate line x on y, and then we'll calculate line y on x. So first line x on y, x minus x bar, bxy, y minus y bar, equation number 1. So first we'll have to calculate x bar and y bar. So let's calculate x bar and y bar. X bar is equal to summation x upon n. Y bar is equal to summation y upon n. Summation x is nothing but the total of x. So if you calculate the total of x, it is 30, and then the total of y is 40. Okay. So this is 30 upon 5, and this is 40 upon 5. I'm not dividing this at this particular moment. We'll just do the divisions later on. Okay. So we got the value of x bar and y bar. X bar, y bar values we have calculated. bxy is nothing but the regression coefficient of x on y. So the formula is covariance between xy upon standard deviation of y square. Equation number 2, right? Then we'll calculate covariance. Covariance between xy, which is summation xy upon n minus x bar y bar. Okay, so n is 5, then our x bar and y bar is 30 by 5 and 40 by 5. 30 upon 5, 40 upon 5 will rely heavily on LCM. Now summation is besides xy. If you observe, summation is besides xy. So just calculate the total of xy by creating a column. So this is 54 and then 22, 50. Just multiplying the two numbers over here, x into y. 32 and then 56. And if I calculate the total is 214. Okay, so 214 upon 5. So that is 214 upon 5 minus 1200 upon 25. Once again, take the LCM, multiply and divide with 5 so that the denominator remains same as 25. So 214 into 5, that will have to multiply, right? 1070 minus 1200 upon 25. So that is minus 30 by 25. The covariance value can be negative, okay? It can be negative. Yeah. So we have calculated the covariance. Now we are supposed to calculate the standard deviation of y square. So for that, we'll first calculate variance of y. So summation y square upon n minus y bar square. Okay, y square upon n minus y bar square. Then n is 5, y bar is nothing but 40 upon 5. Okay, so we'll have to put a square over here. Summation y square, summation is besides y square, so we'll have to create a column of y square over here. So 81, 121, 25, 64 and 49. So if you calculate the total of this, it turns out to be 340. So this is equal to 340 upon 5. So 340 upon 5 minus 1600 upon 25. I'm not relying on division, I'm relying on LCM. So to make the denominator same, multiply and divide with 5. So this turns out to be 340 into 5. That is what we'll have to do. 1700 upon 25 minus 1600 upon 25. So that is 100 upon 25. That is variance of y, right? Now standard deviation of y is equal to root of variance of y. Squaring both the sides. See why we have to square, because we require standard deviation of y square. Squaring both the sides. So this is equal to variance of y after squaring. So standard deviation of y square is equal to 100 by 25. So we have both the quantities over here. We have got standard deviation y square. We also have got covariance, right? So what I'm going to do is I'm going to standard deviation of y square is 100 by 25. minus 30 by 100, 0, 0, 0. So understand, if we don't divide at the beginning, the end part becomes very easy. Okay, so don't divide again and again. Rather rely, you can also rely on LCM, otherwise it is your choice, right? So we got bxy from equation number 2. Now from 1, now we'll put all the divided values. Equation number 1, x minus x bar. So x bar is nothing but 30 upon 5, which we can write now as 6. Then this is minus 0.3 minus y bar. Y bar is equal to 40 upon 5, which is equal to 8. Right? So it's minus 6 minus 0.3y plus 2.4. So x is equal to minus 0.3y plus 6 plus 2.4. So x is equal to minus 0.3y plus 8.4. So this is your line x on y. Just mention that this is line x on y. So one part of the problem is over. We have calculated the value of line x on y, right? Now secondly, we also have to calculate the other line, that is line y on x, y minus y bar, byx, x minus x bar, equation 3, byx, covariance of xy, standard deviation of x square, standard deviation of x square, right? Equation 4. Now we already have calculated covariance of xy earlier for first part of the problem. Okay, so first we'll calculate variance of x now, because we require standard deviation of x square. Summation x square upon n minus x bar square. So summation x square, summation x square. So x square, just make a column of it. Thirty-six, 16, 64. Okay, and the total is 220. So let's take 220 upon 5 minus 30 upon 5 the whole square, right? So 220 upon 5 minus 900 upon 25, multiply and divide with 5. Okay, because we are making the same denominator. 220 into 5, that is 1100. Okay, upon 25 minus 900 upon 25. So this turns out to be 200 upon 25. That is variance of x. Standard deviation of x is root of variance of x. Squaring both the sides. We have squared both the sides. So standard deviation of x square is equal to 200 upon 25. Right? Then, now this time we'll go to equation number 4. Put the values of covariance and standard deviation of x square in equation number 4. So from 4, byx is equal to covariance. Now covariance is minus 30 upon 25, right? And standard deviation of x square is 200 upon 25. So 25 gets cancelled, and this will be minus 30 upon 200. Okay, so what we are going to do is we'll just reduce this. This will be 15 and this will be 100. So this is minus 0.15. The value of regression coefficient of y on x, that is byx, is minus 0.15. So from 3 this time, from 3, y minus y bar, byx, x minus x bar. So all these values we have calculated, y bar, x bar and byx values we have already have. So y minus y bar is 8, 40 upon 5, that is 8, minus 0.15. x minus 5, 30 upon 5, which is, one second, 30 upon 5, which is equal to 6. We'll take this as 6. Okay, now further you can simplify this and you can get the value of x on y. How to simplify? Just multiply this with both the terms, shift this minus it on the other side, and then you can simplify. So we have solved one more problem in which I have demonstrated how to calculate the equation of line y on x as well as line x on y. We'll take one more example. Okay. Okay, so let us take one more example, which is from the government textbook, exercise 3.1, question number 1, page number 41. Page 41, okay. The HRD manager of a company wants to find a measure which he can use to fix the monthly income of persons applying for the job in the production department. As an experimental project, he collected data of 7 persons from that department referring to the years of service and monthly incomes. So first we'll write down what is X and what is Y. So years of service is nothing but X, and monthly income is Y. Years of service is X, monthly income is Y. Okay. So first thing that they're asking is equation of income on years of, asking equation of y on x. Okay. So this is the first part of the problem. They're asking equation of y on x, right? So x and y data is given to us, x and y data is given to us. Okay. So 11, 7, 9, 5, 8, 6, 10, and 10, 8, 6, 5, 9, 7, 11. Okay. So we were in x. X is nothing but y minus x bar. So y minus y bar. First we'll have to calculate x bar and y bar. So x bar is summation x upon n, and y bar is summation y upon n. So x bar is 56 upon 7. Y bar is also 56 upon 7. I'm not going to divide this. Instead, I'm going to play with LCM. Okay, so this is equation number 1. Then regression coefficient of y on x is byx. So byx is equal to covariance of xy upon standard deviation of x square. Equation number 2. Equation number 2. Fine. So covariance between xy summation xy upon n minus x bar y bar. This is what we have been doing since the first problem today, right? So this is 56 upon 7 into 56 upon 7. Okay, and this is also 7. Summation xy, we'll have to prepare that column. So 110, 56, 54, 25. This is 72, 42, 110. The total is 469. So this is equal to 469 upon 7. So we'll multiply and divide with 7. Okay. This is also 56 into 56, 7 into 7. We'll just multiply 469 into 7. Okay. So I'm doing it. 3283 upon 49 minus 56 into 56, 3136 upon 49. So you can minus this 3283 minus 3136, which is 147 upon 49. So this is the value of covariance between x, y. Okay. Then we'll calculate standard deviation of x square. For that, first we'll calculate variance of x. Variance of x is equal to summation x square upon n minus x bar square. So this is 7, this is 56 upon 7 the whole square. Summation x square, we need to calculate the total of x square, column x square. So x square is equal to 121, 49, 81, 25, 64, 36, 100. So the total of this is 476. So this will be 476 upon 7. So 476 upon 7 minus 56 into 56, 7 into 7. We'll take LCM. 476 into 7, 7 into 7, 56 into 56, 7 into 7, right? 56 into 56 we have already calculated in the previous slide. So that is 3136 upon 49. But then 476 into 7, that will calculate. 476 into 7, that is triple 32 upon 49. We will subtract this 196 upon 49. Okay, we got the variance of x. So standard deviation of x is root of variance of x, squaring both the sides. Okay, so standard deviation of x square is equal to 196 upon 49. Okay, so from equation number 2, what we can do is we can put the value of covariance and standard deviation of x square. Covariance of xy is 147 upon 49 and standard deviation of x square is 196 upon 49. So byx is equal to 147 upon 49 and this is 196 upon 49. Okay, so just cancel 49 and see to it if we can reduce this further. Okay, so let me check. 196, is it divisible by 7? Yes, it is divisible by 7. And 147, obviously it is divisible by 7. 147 divided by 7, that is equal to 21. And 196 divided by 7, that is equal to 28. So this is 21 upon 28, right? Once again, it is divisible by 7. So 7 3s are and 7 4s are. So byx is equal to 0.75 once we divide 3 upon 4. So from equation number 1, y minus y bar, byx x minus x bar. Now y bar and x bar will take 8 and 8. So y minus 8, 0.75 x minus 8. So y minus 8, 0.75 x minus 75. 0.75 into 8 will have to multiply. 0.75 into 8, that is 6. We'll go to the next page. So y is equal to 0.75x minus 6 plus 8. Y is equal to 0.75x plus 2. This is line y on x. This is line y on x. Now if you go to the next part of the problem, what they're asking is what initial start would recommend for a person applying for job after having served in a similar capacity in another company for 13 years. So a person is having an experience of 13 years. So service, years of service. Years of service as 13 years. One second, let me just confirm. So income is Y and years of service is X. So why they are asking? So Y depends on X. Okay. Use line Y on X. Use line Y on X. And line Y on X we already have. See, we have calculated line Y on X. So in this, put X as 13. So 13 plus 2. So in in Y column, if you refer the basically I was trying to make you understand that Y is equal to 0.75 X plus 2. Put the value of X as 13. So 9.75 plus 2, which is 11.75. The Y data is given in thousand, so multiply this Y value with 1000 because that is the income. You can refer the textbook. The Y values are in thousands. Okay. So rupees 11,750. That is the income Y. So that is the end of the first lecture on the tabular format sums in this chapter. Okay. Thank you.